So today we are going to concentrate how the machine code is generated. Okay. The example for today is only two very common command that we are going to use: clear and move. Okay. So this is very important because you have to know how it works, and if I have to give you a data sheet, I'm going to give you another data sheet, which is nearly the same, but you have to answer, you have to understand how to read the data sheet. Okay, when you compile these long codes, each of the command syntax have its own machine code. Okay, you compile it. And we have all the answers. In simulator, you can see directly because the computer changed it for you. So this is a command line, this is a command syntax that you typed just now. And you look at over here, this is your memory location, and this is the instruction, this is the machine code. So now, we want to find out, we want to know the process on how to get this command changed to this machine code. Alright, so now you have the answers here. But how? You need to know. Because in the final exam or the midterm, I don't give you answers. I only give you data sheet and the command. Okay? You need to read the data sheet correctly. You need to fill up correctly based on the data sheet. Okay? It can be anything. It can be any command I can give you. So right now, the command here is very simple. First, clear.byte $1000. There's no hash, only symbol of $. Symbol of $sign means that it's going to the memory address location. But now there is only 4 digits 1000. 4 digits means it's absolute short. 6 is absolute long. Okay? Now go to your data sheet. Clear data sheet is like this. Sorry. Okay, this is your clear data sheet. What you need to know that this, inside the data sheet, this is the instruction format where it converts the value from binary to hex, which is the machine code. So each of the data sheet is different. So you have to refer the correct data sheet before you do the conversion. Now for clear instructions, you have to use this data sheet. It's clearly stated at the first line over there for the clear instructions. So no matter what, normally it's 16-bit size, the instruction format over here. For the clear syntax, the first 1, 2, 3, 4, 5, 6, 7, 8, the first 8 bit is confirmed fixed numbers based on this data sheet. So no matter what, this is a number that you're going to use. The rest still open to be filled out accordingly to the syntax and accordingly to the data sheet. Okay? So right now what the thing that you need to do is you write down whatever number that is already fixed, which is 0, 1, 0, 0, 0, 0, 1, 0. Now you have to fill up this one. The first command is clear.byte, betul? Clear.byte D berapa? The one that I asked you just now is D5 inside the command, inside the scene. Clear.w D5, the first command just now. Clear.byte 1000. No, look at the one that I asked you to write down in the simulator. Clear.byte 1000. You compile it, you can get the answer already. This is the answer 4238. Okay, 4238 the answer. But how? So now we need to find out more. That just a clear.byte D8 Clear.byte just now what? 1000 Clear?
First, clear.byte 1000.
Clear.byte $1000. So this is my instruction. The machine code is converted based on this instruction format. So the first 8 bits is already given here. Now fill up this size number. Size is accordingly to this instruction. Your size command is what? Clear.byte. Byte is what? 00. Byte is 00. Now is the effective address for the mode and the register which is coming from one of the table contents over here. So which one that you need to pick up? For the mode and the register, or for the mode and the register? So which one? Based on this syntax. $1000 is the pattern for the absolute short. It's only 4 digits. Direct memory. So inside the table here, absolute short is referring to this one, xxx.w. That is absolute short. So from this table line, you have the mode, you have the register. You fill up this mode and the register accordingly to the table there for the absolute short. Now the mode will be 111, which is you're taking from this one, and the register is 000. You complete all the 16 bits already.
Why we didn't use the second? Because you have L and W.
L is for the absolute long. Absolute long means minimum 6 digits. Now you have the whole 16 bit. Convert it to hex. Very simple. In the method, you just need to convert, divide by 4 every time. Not divide by 4. Section 1, 2, 3, 4. 1, 2, 3, 4. So this is the division. Convert to hex. This is equivalent to what? This is equivalent to 8. This is equivalent to 3. This is equivalent to 2. This is equivalent to 4. Is it the same answer with the simulator? That is the answer for the machine code. The one that you simulate just now, which is here. Here is the answer. 4238 is the same one that I have. This command for the machine code is this one. This command for the machine code is this one. But how? You need to know that how to read datasheet. This command is this one. This command is this one. For the move command is this one. Move.w is this one. And move.long is this one. Okay, now do it again. For the clear.wd file, do it now. You have the answer, and try to figure out from the 16 bit that you have from the datasheet, come up with this answer. Let's check whether you understand or not. Clear dot WD5. Look back at the data sheet, fill up those blank bits. one, clear.w d5. Everybody got the right answer or what? So you don't want me to teach you? So okay? So let's try again. I just show you, just show you. I just show you maybe 2 or 3. Let's clear this one first. Yes, right.
When it is numbers,
6 number means absolute long. Absolute long means you have to use the xxx dot l. Then there's no numbers. You look at over there at the table. They're giving you the mode and the registers. It's a direct one. Yeah, it's a direct one. You check. You have to pick from the table. The table say what? So clear dot by. Okay, now try clear dot w d2 d5. Sorry. The first 8 bit is permanent the same. 0, 1, 0, 0, 0, 0, 1, 0. Okay, now the command for clear.wd5. The size is W. W means what? What the value for W? 0, 1. 0, 1. And then D5, you need to go to the table first. D5, so which one do you need to pick? D5 pattern, command, you need to fix this one. DN, the mode will be 0, 0, 0. And the register number, what does it mean? What is the register number from the case just now is D5. So register number is 5. You have to convert number 5 to binary. So the mode is 0, 0, 0. Number 5. Mode but this one, last one, now. Number 5. 5101, right? 101, correct. So the answer is 5, 4, 2, 4. It's the same answer in the simulator. Is it the same answer simulator? 4245? Is it the same or wrong? The answer must be 4245 from the simulator for the clear.wd5. The answer is 4245, correct? Right? Then next one. Clear.long brackets A2. Clear.long bracket A5. This is the first. Clear.long A2. Clear.long A2. Okay, now look at the instruction code again. This is the same one. 0, 1, 0, 0, 0, 0, 1, 0. Size now is long. Long means what?
1, 0.
Long means 1, 0 here. This is the command for indirect So from the table, which one are you going to use?
Second one.
The first one, third row, right? This is the pattern, bracket address register. So the mode will be 0, 1, 0. And this one is the register number. The register now number 2. So you binary is 0, 1, 0. So divide by 4 sections again. So the answer will be 2, 9. 9, 2, 4. Is it the same? So the machine code is 4294 hex. Same? Objection? I compile it for you. Okay, next one. Clear.byte $800,000. That is basically a dollar sign only, so means that is pointing to the memory location, and the addressing mode that is for the absolute long, because its minimum number should be 6 and above. 4 is absolute short, 6 is absolute long. So right now you have to go back to the data sheet. Data sheet same thing. So put down first again this one 0 1 0 1 0 0 0 0 1 0. Size is byte. Byte is 0 0, and the addressing mode for the register. Mode and register, which one is it to pick? Pick this one. This one. You have to use this one for the absolute short pattern, which is this one. It's absolute long, sorry. Absolute long. So the mode will be 1 1 1. Register is fixed, It's a fixed over there. 0 0 1. So divide by 4 sections again. 1 2 3 4. So this one will be 9 3 2 4. So this is the same one like the simulator says. Is it the same? Simulator say the same thing for the answer. Ada yang dapat lain? Ada yang jadi PC lain? Anybody another CPU over here? Anybody has different ALU today? Okay, faham semua, right? Is it okay? So now move to the another instruction, another data sheet. Let's go for the move data sheet. So the move data sheet is a bit different.
Yes.
Because of what? Because in move instruction, you have source, you have destination. Clear syntax just now, you don't have source and destination, you just clear something. But in move, you have to move something here to here. Remember that, right? So means that you have the source, you have destination. Example, very simple here. Look at the table here. This is for destination. This is for the source effective address. This is the instruction code 16-bit. So you have to refer to this. For this 16-bit, only 2 is permanent numbers. The rest you have to fill up. Okay, let's look at the first command. Move what just now?
Move B
In the
move B to D0.
move dot by
D0 D1.
D0 to D1. So now ialah move dot by D0 to D1. You have the source here. You have the destination over here. The last one is destination. So right now you have to fill out first. The first 2 digit is the same one. What is this? The first 2 digit is 00. Next is the size. The command is now byte. The size will be from this code, from this data sheet. The size will be byte is 01. The byte size is 01. Now look at over here. This section is for destination. This section for the source. So look at the destination first. Destination is D1. Destination D1. So look at the table. Which for the destination is over here? You have to refer to which part? The first one, because it is a data register. So you have to fill up here register number. This is register number. Register number is the register number. So it's D1, correct? So the number will be 001. You convert number 1 to binary is equivalent to 0001. The mode you just take from here. Mode is 000. Now move to destination for the